Hey guys, so today we're going to talk about the public key cryptography. It is a method for one person to send a message securely to another person without any other person knowing what this message is. So what Bob is going to do, let's say Bob is the receiver. Bob is going to determine two primes. Let's say one prime is 13 and the other prime is 17. Bob is going to multiply these numbers to get n. N is equal to PQ, and when you multiply them, you get 221. Bob is also going to get a number M from P minus 1 multiplied by Q minus 1, and it is going to yield him 192, since 12 times 16 is 192. And now Bob is going to find a number E such that 1 is less than E is less than M. So E has to be between 1 and M, but it cannot be 1 or M. E also has to be co-primes with M. E and M do not have to be prime numbers. They can be any number as long as their greatest common factor is 1. So in this case, Bob can say, I want E to be 35. Alright, there is no other common factor between 35 and 192 except for 1. And now, Bob is going to do something interesting. He wants to find a D. So to find D, we want D to be a number such that ED is equal to MK plus 1. And K can be any integer. So MK means a K multiple of M. So what this means, plugging in the numbers that we know so far, 35D is equal to 192K plus 1. In other words, it is equal to 1 mod 192. So plugging it into a calculator online, we can find a D equal to 11. So now, Bob will tell Alice only N is equal to 221 and E is equal to 35. And what Alice is going to do is, her original message is 20, 50, 69, 3, 1, 1, 10. So if we label them, we can say C1, C2, C3, C4, C5, C6, and C7. And Alice is going to use the numbers Bob had given her to encode the message into something different. So she does. For each C, she puts E as a power of it, mod N. For C1, Alice is going to do 20 to the power of 35 mod 221. And if you plug in a calculator on this website, you will find that it is equal to 197, of course, mod 221. If you do it for every single element, then you would find a final message that becomes 197, 84, 205, 61, 1, 1, and 82. So now Alice says, hey Bob, here you go. So Alice sends Bob this encoded info or message. And now Bob will decode using his private key. D is equal to 11. Why is this private? Because this is the thing that only Bob knows. Like E and N, Bob has to republish them online to be able to let Alice know. But 11 is the number that only Bob knows. And that's the solution to decoding this message. So what Bob is going to do is, he will, for every element, get a power to D and mod N as well. So this will be, for the first number, 197 to the power of 11 mod 221. Plugging it into a calculator, we find it equal to 20. If Bob does it everything, then he would eventually find the original message that Alice wanted to send. 20, 50, 69, 3, 1, 1, 10. And this is how you do public key cryptography. In this case, two keys are used. Bob has a public key that Alice knows, and he also has a private key that helps himself to decode the information that Alice has encoded. The theory behind this method is pretty complicated, so I would suggest that you read some papers to figure it out. But otherwise, this is a pretty useful method the next time you want to send your friend a secret message without other people knowing. Thank you guys so much for watching today's video. Be sure to check the website out and see you guys next time.